Good morning, everybody. Okay, my OBS window seems fine. Yesterday we started talking about unnamed namespaces. They are very useful namespace types. As the name implies, they are unnamed. We don't give them names. So it comes to mind, how can we use a namespace without a name? We have such a namespace before, global namespace. Global namespace didn't need a name. It doesn't have a name. If you don't specify a namespace, it goes to the global namespace. So what is unnamed namespace? Unnamed namespace is not like that. With the unnamed namespace, you say that, okay, this is my unnamed namespace. And that unnamed namespace is only valid in the same compilation unit. Same compilation unit here. Same compilation unit. What's the compilation unit? As we mentioned yesterday, compilation unit is the file along with all the files included in the file. For example, an unnamed, let me show you an unnamed namespace. Okay. This is my unnamed namespace in this file, dime.cpp. Okay, dtime.cpp, digital time cpp. My unnamed namespace starts at line 12. As you see, it doesn't have a name. It includes these helper functions, and it ends at line 75. Okay, so this is my unnamed namespace definition. The functions, the global functions that I remember that I didn't like these global functions. I said that these should not be part of the class. They made them global functions, but these global functions belong to the unnamed namespace, and this unnamed namespace is only valid. This unnamed namespace is only accessed only in the compilation unit of dtime cpp. Okay, compilation unit of dtime cpp. Okay, this is our regular namespace, dtime savage. Dtime savage is available everywhere. As long as you say you using namespace dtime savage, it is valid everywhere. But this unnamed namespace functions, okay, whatever we have inside these functions, are only valid in the compilation unit of dtime. What is the compilation unit of dtime? All the code expanded from this C-type H, CSE241 H, dtime H, etc. So if I am compiling this with a minus E option, I am expecting this to be more than 30,000 lines of code. So this 30,000 lines of code can have access to these functions: digit to end, read minute, and read hour. Okay, so that's the definition of unnamed namespace. So it looks like unnamed namespace is kind of a different version of encapsulation. It's a place where you can put these kind of functions of classes, which should be accessible in the same compilation unit. Okay, remember, I mean, that's not that I am being very careful about. I am not saying the same file. Okay, compilation unit is something larger than the file. Okay, it includes the whole header files and everything. Okay, so this unnamed namespace, any function defined in the unnamed namespace, is accessible to all the elements of the same compilation unit, including these functions. Okay, for example, this read hour function. Okay, I am calling this read hour function from the stream extraction operator, right? With no problem. It looks like it's a global function, And in fact, it's a global function only inside this unnamed namespace. Okay. So it looks like my chat window started working again. Atakan is asking me a question, so you can. Still, we don't like unnamed namespaces. We don't like global functions, no. But sometimes we have to. Sometimes we need that kind of stuff. So it is better than making them. It is better than making them pure global functions. It is better than making them parts of our classes, right? So make them parts of unnamed namespace, and nobody will have access to it other than the elements in the same compilation unit. What is wrong with the global functions and global variables? We said that we don't know who is going to modify them. We don't know who is going to call them, right? There is no way to restrict it. So what kind of things are they working on? We don't know. So this is a way of restricting your global functions and global variables to some kind of a scope. You say that these functions are only valid inside this file along with its unnamed namespace. So we still don't like global functions because in object-oriented programming world, everything is about classes. All the functions should have their should belong to some kind of a class. And in Java, we are gonna see examples of it. It is not that difficult. I mean, in Java. So how did they solve this problem? For example, the function sine or cosine. I need to take the sine of a number. I need to take the square root of a number. How am I going to do that? They said that there is a class math. Okay, there is a class math class. Okay, there is a math class. And inside the math class, there is a static method. They call it method named sine. So if I send 1.0 to sine method, it's going to return me the sine of it. Okay, so it's as simple as this. So it looks like it looks like a global function, but it is not. This is part of a class. It's a static. I don't need an instance of this math class. Okay, this is something similar. I mean, I am restricting these functions to this compilation unit only. No, because as you see, it is not because if you have a friend function, that means that it's not part of the class, and that means that somebody is going to call it, right? It's the part of the public interface, right? If it is a part of the public interface, then there is no point making it part of the unnamed namespace because nobody can call it now. Because it's part of the unnamed namespace. Unnamed namespaces cannot be accessed outside of this compilation unit. For example, in this case, let's say I am going to write a. See, this is how clean this interface is. I don't have any private stupid functions anymore. And let's write some code to use this digital time class. Okay, with the digital time class, this is my main, and I write my everything. Okay, and I include dTime_h, and I just use it. By the way, there is a function named readHour here, and by coincidence, it is the same name as this readHour. Of course, they made it on purpose. Okay, let's talk about this readHour. What is the namespace of readHour in this file, timedemo.cpp? What is the namespace of this readHour defined at line 7 of this file? Yes, exactly, Mustafa. Global namespace. Okay, readHour belongs to global namespace, but this readHour in the dtime CPP belongs to unnamed namespace of compilation unit of dtime CPP. Okay, compilation unit of DTime CPP. Okay, so let's go to that one. And this readout is completely a different global function. It's a global namespace, global function. Still, we don't like it, but as you see, these are the compiler sees them as two different functions. Okay, Mehmet Hussein has a good question. How can we access the unnamed namespace from the outer? I think he means that how can I access the unnamed namespace of DTime CPP from timedemo.cpp. For example, instead of accessing this readout, global namespace readout from this file, I like to access the readout of DTime CPP. The answer is you cannot. That's the purpose of the unnamed namespaces. There is no way, okay, there is no way you can access the unnamed namespace of some other compilation unit. That's the purpose of it. That's why it doesn't have a name. How do we access it? How do we? Okay, we say using std cout, right? We say this. Okay, so that means that there is a namespace named std, and I'm going to use a name cout inside that namespace. Okay, how am I gonna access the unnamed namespace of some other file? When you say using, I need a name here, right? I need a name before read our. Okay, I need a name here. The unnamed namespace doesn't have a name, so I cannot do that. Okay, there is no way, Mustafa or Mehmet Hussein, there is no way you can access an unnamed namespace from some other compilation unit. They are only valid inside the same compilation unit. Mustafa says that he doesn't understand the compilation unit. We talked about it yesterday, Mustafa. This is the definition of the compilation unit. A file along with all the files included in the file. Okay, so remember the example that I gave you yesterday? Okay, let me show you that file. Okay, I think it was test, CPP test. Okay, I think let me first.cpp. Okay, first.cpp is a very simple program. It is like 15 lines of code. Okay, so the compilation unit of this first.cpp is this file along with all the code that is included. See, I am including this iostream.h. Whatever code comes from the iostream.h, my compilation unit includes that code too. So remember yesterday, what did I do? I think I compiled, I compiled first.cpp with a -e flag. So it produces the expanded version of first.cpp. And let's see funit cpp. funit cpp is this file. It is produced from first.cpp. Okay. See, it included iostream.h, and it has all kinds of code. See, it is a definition. This is nice. It is the definition of the std namespace. There is a size t of malloc is a long unsigned integer. Okay. So what else? Null ptr. Okay, that's good. Type def, declaration type of null ptr. Okay, this is, remember the null ptr? Say that my null ptrt is the same as this one. Yeah, okay. Let me, it is fun to look at this kind of stuff. Again, I am adding some other stuff to namespace std. Inline namespace. Oh, it is defining another name inside this namespace. Oh, okay, it is a C++ 11 attribute, and I did not talk about this kind of namespaces. I am going to skip. These are some compiler directives. Okay, we didn't talk about the templates, but Again, these are all parts of the standard namespace. It goes like that. And if I go to the end of the file includes my small first.cpp. So the unnamed, my connection is acting up again. My connection is acting up again. It should be fine now. Yeah, I think it should be fine. No, it is not. Yeah, I think it is. Yeah, okay. So unnamed namespace of first.cpp is this whole file, the 28,000 lines of code. Okay. Let's see if I have any unnamed namespaces in this. Can I, how am I gonna find it? When I say namespace, there will be lots of these are all namespace stds. I was wondering if there is any unnamed namespace definition inside iostream.h. There could be. Okay, there are many other namespaces that we don't know. Swappable with details, whatever that means. So they are using these kind of secret namespaces inside the, yeah, see, there is a funny name namespaces there. So they are all, I think, hidden. They will be turned on when you switch some of the compiler flags, maybe. I could not find it. So that's the definition of unnamed namespace. Who asked that? Mustafa, is it okay, Mustafa, now? If you like to think in a very simple way, this is not correct, but if you like to think it in a simple way, unnamed namespace is only valid inside this file d times cpp. Okay? But it is wrong. It is larger than that. It includes all the includes of all of this file. It is much larger than that. Okay. Okay. So if you let me do this. Let me do this. This is something stupid, but it's a good exercise. Okay, I'm going to do something stupid. I erase all of it. I erase the unnamed namespace of d times cpp, and I pasted this in the header file. Okay. So this unnamed namespace is in the d time h. Okay, now tell me what's going to happen. Okay, now tell me what's going to happen. Okay, this thing. Can I? Come on. Okay, I'm going to switch to wireless network. No, it cannot. Let's try this one. Okay, so if I do that, is this code compilable now? D times cpp. Remember, I copied that unnamed namespace in d time h. I copied everything to d time h. Is this code compilable now? D times cpp, because it needs read hour. It needs read hour here, right? It needs read minute, and I don't see any definitions of it inside this file. Are you guys hearing me?
Yes, sir. We can hear you.
Oh, sorry, I am my my volume was turned down. Sorry. Did you say, are you guys hearing me? I think compilable because we include time age. Yes, exactly, Jakub. Atakan said no, Hayrettin said no, Jakub said yes, Mehmet said yes, yes. The answer is yes. Why? Because unnamed namespace inside the time age, okay, is the same unnamed namespace of this d times cpp, because remember the definition of unnamed namespace? It is the file along with all the included code. So I am including d time age here. Since I included d time age, the unnamed namespace of d time age is my unnamed namespace, right? So it is the same unnamed namespace. When I do that, okay, this read minute, or read hour will work fine, no problem, because it is the same unnamed namespace. That's why I'm being very careful about compilation units. Compilation unit is not the same as the file, okay? We shouldn't say that unnamed namespace is only valid for the same file. We should say that unnamed namespaces are valid for the compilation unit. Okay, since I am including this d time age in this file, my unnamed namespace and that header file's unnamed namespace is the same thing. Okay, let's come to this one. How about now? Is this code compilable? Time demo CPP. Yes, exactly. Yeah, no, because there will be two read hour functions. One is the global namespace, which is directly accessible. The other one is, again, in my unnamed namespace of this compilation unit, time demo CPP, I included the time age. So as you see, these functions in the unnamed namespace of the header file can belong to many compilation units. Okay, so you should be careful when you are doing the unnamed namespaces inside the header files. Okay, inside the header files. Okay, good. So I think this was it. Don't do this. This is stupid, as I said, but it's a good exercise to know what's going on. Okay, let me do this. Remove this thing. Remove it. And paste it back in here. Okay, good. So let's go back and talk about unnamed namespaces. Global versus unnamed namespaces, they are not the same. Okay, with the global namespace, this is what we do with C. Okay, so we call that global namespace. Okay, and C++ people likes this a lot. They tell C people that what you are doing actually global namespaces. Okay, you didn't know it's a global namespace. When they use the structs, they tell C people that what you are doing is just encapsulation. The only thing is that you are not putting functions in it, etc. So they kind of say that C is a specialization of C++. C++ is more general than C, so that we can be compatible with C. Okay, so with the unnamed namespaces has namespace grouping. Okay, it just has no name and local scope. With the global namespace, it is only accessible. We don't like global namespace, but unnamed namespaces are okay. By the way, unnamed namespaces are not for just global functions. You could put your helper classes, you could put your helper other definitions, type definitions, and etc. inside the unnamed namespaces if you don't like them to be seen by other people. Okay. It is possible to have nested namespaces inside a namespace like this. Okay, S1. I can have another namespace. So if you like to access this namespace here, it would be like that. Okay, so to access it, there is a namespace S1, inside it there is another one, and inside there is this sample. Okay, good. So we prefer to hide our helping functions, global functions, inside our unnamed namespaces. Previously, we make them private and static. We made them private because we said that this is not part of the interface. You are not supposed to use them. You are not supposed to see them. Okay, we are ashamed about them. We are embarrassed about them. But they are global functions, and we need to hide them in some way or the other. So we made them private and we made them static. We made them static so that we are telling everybody and compiler that these functions will not have an access to the data. Public or private data doesn't matter. So these are static functions like global. Still, I don't like it. The better place to put them is the classes implementation unnamed namespace. Okay. In that unnamed namespace, in that compilation unit, those functions are available like global functions, but at least I know them. Nobody other than myself as a developer is going to call them because they even don't know they exist. Okay, they are not part of the header file. Nobody will see it. Okay, and even if they have the code in them, in their hand, they cannot call it because there is no way to call them. Okay, this is cleaner code. So this thing, remember our money class, there were these three functions, the integer part, and the dollars part, and the cents part, and the round, and that kind of stuff. Those were helper functions and they were global. We didn't like it globally. We didn't like it in a private, and we made them static. Still, we didn't like it. Now there is a good place to place them. Okay, they are not global. They have local scope. Their access is restricted. Okay, good. So this is the end of this file. And if you have any questions about separate compilation or namespaces, just ask now. It's a good idea to go read that, remember, funit.cpp that I have produced. I mean, just try to understand what is going on. It is lots of namespace definitions, lots of other definitions, and there are many things that I didn't talk about. Pragma statements, compiler directives, right? And try to understand what is going on, and I think you have enough knowledge to understand most of it, other than the templates maybe. Okay, good. So that's it for this chapter. Let me start a new chapter. By the way, okay, it's time to talk about the midterm exam. Your midterm exam will be next week, Wednesday. Okay, it's going to be an online exam, and you are supposed to, what you need is a computer with a camera and a microphone and a good internet connection. Okay, midterm exam is next week. So next week, Wednesday 9th, okay, December the 9th, okay, 2020 at class time. So it's going to be a 2-hour exam between, okay, 8:30 and 10:30. Okay, between 8:30 and 10:30, and what you need is a computer with internet connection, camera, and microphone. Okay, we will be recording everybody, so you will have a nice space, and then your exam will be similar to what you did last year, in C course, 102 course. Okay, and we are gonna grade it that way. Okay, so tell everybody. So I have how many people in here? Like maybe 90 people. And tell everybody that this is our midterm exam time. And midterm exam will cover everything from beginning of the semester up to this point. I'm going to start talking about inheritance. Inheritance will not be included in the midterm exam. So it will cover everything. We covered chapter 12, right? Ilhan covered chapter 12, I know. Let me see. From chapter 1 to, okay, from chapter 1 to, at the end of chapter 12. Okay. End of, okay, chapter 1 to chapter 12 included. Chapter 13 is not included. Inheritance is not included. Is not included. Okay, study hard. Remember what we have told you. Okay, try writing lots of code, and don't forget writing code on a paper, because you will be doing everything on a paper. The computer is going to be for camera and the microphone only. Okay, you are not supposed to touch your computer during the exam. Everything will be done on a paper. So like I am writing code on my screen, you are going to write your code on a paper. And the exam will be like that. Okay. Okay, if there are no questions, let me start the new chapter, inheritance. Chapter 14. I skipped chapter 13, which is about recursion. I will come back to it, and I will talk about it. And I will talk about it later. Ahmed Fred, how are we gonna upload our papers? We will send you the instructions during the weekend, okay? How many questions? I think there will be 4 questions. I think there would be write a function kind of stuff. Maybe then write a few small classes. Do some other stuff. Okay, 3 or 4 questions. So 120 minutes should be enough for you. Okay. Okay, let's start talking about inheritance. Remember at the beginning of the semester we said that there are some fundamental rules of object-oriented programming. Object-oriented programming fundamentals. We said that encapsulation is one of them. Okay, related to encapsulation is abstraction. Encapsulation is putting the data like a struct together, but then you put the related functions in the same capsule, and then abstract away all the details of how I am doing things. Okay, the important thing is my interface. I expose my interface to the customer, but I hide away, abstract away all the details from the user. Okay, these are 2 golden rules of object-oriented programming. Okay, then there is this other fundamental, inheritance. And related to inheritance, there is the other thing, polymorphism. Okay, these four things are the fundamentals of object-oriented programming languages, and we have seen two of them. And when we talk about inheritance and polymorphism, they will make more sense. We do all of them mainly for, again, code reuse. Okay, code reuse. If we apply these rules to our programming projects, to our software development process, the theory says that, the practice says that you will write reusable code. You will write clean code. Your code will be clean in a way that it can be used by some other people. It can be used by yourself in other projects. And it will be a low maintenance code. What do I mean by low maintenance? If there is a problem, it would be easier to fix, because all the code knows where it works. It doesn't have any side effects. If there is a problem with one of my functions, I know that that function belongs to a class, and I know where it affects, right? Because that function cannot do bad things about other classes, right? So it is easy to locate the errors. It is easy to fix them. And if I like to make a change, in my code, I can do it freely, especially if I am not changing my interface. My change is not going to affect anybody else in the project. Let's say if I have a 10 developer project team, and everybody is working on tens of thousands of lines of code. Okay, if I make a change in my code, how should I be sure about nobody else is going to be affected? Well, if I am not changing my interface, everything should be fine. So this separation of interface and the implementation is a very nice thing. So these are all very nice rules, very nice discipline rules. And if I apply them, as again, my code will be reusable. Inheritance and polymorphism is similar too. They are writing about very reusable code. They are writing about very generic code. Or general code. The code that I write should be generic, so it is applicable to many places. That means that it is reusable. Okay, so inheritance and polymorphism, especially polymorphism, is about writing generic code. I am not writing specific code to my project. The code that I'm writing is very generic, so it could be reusable, okay, or it could be very easily extendable to other projects. Okay, this is about inheritance. Okay, so by the way, when I introduced you how we do the inheritance in C++, there is very little syntax about it. Okay, C++ part, it is only very little. Maybe I will show you just one or two syntactic features of it for whole inheritance, then that's it. But the idea of inheritance is very big. Sometimes it will take you a few thinking about it. But syntax-wise, it is simple. But idea-wise, the philosophy-wise, it might take some time to understand it. Okay. So instead of talking about what the book says, let's look at the code given by the book. Okay, I'm going to close the stuff. Close it. No. Time demo, we don't need them now. Okay. Okay, there is a class named employee, çalışan in Turkish, employee. Okay, and I am going to define this simple class on it. This class has a no parameter constructor. If I am the employee, I should have a name. Okay, name of the employee, and I should have a social security number. Social security number is the maybe TC kimlik numarası in Turkish. Okay, so it's a string because it might have some dashes in it. Okay, so if I am the employee, I need my name and the social security number. Getter for my name, getter for my social security number, TC kimlik numarası, and getter for my net pay, how much I am making. Okay, and my setters for the social security number, name, and these are the setters. These are getters. These are, of course, getters are constant. These are setters, and this print check. Print check is a function that prints my paycheck. Okay, it says that pay this much to this guy. Okay, and in my private part, of course, for my name and social security number, I have two strings, and I have my net pay, how much I am making. It looks like this get net pay is going to return it. Okay, so this is the interface, very simple. So we could have written this class maybe last month, like 4 or 5 weeks ago. No problem. So it's a new class, it's a very simple class. We could have written this class a month ago maybe. We could have written this class a month ago. Okay, it looks like my voice is being recognized. Okay, good. So let's look at the implementation. Just be patient. Okay, this is a very simple class, I know. It's the implementation is here. Again, the nice namespace here. I included everything, including employee.h. And I am, instead of using the whole namespace std, I am saying I need the string and cout, that's it. Okay. So for the class no parameter constructor, I hate these. I mean, these are not good. I mean, they just, name is empty string and social security number, empty social security number. I mean, no name yet is not it's very confusing. I mean, what if somebody has a name, no name yet? How am I going to distinguish it? This is stupid. Okay, so this is better. Okay, so this deliberately empty, of course, and this one, the one that takes two. The name is assigned to the private data member name. The number is assigned to private SSN, and net pay is 0, and deliberately empty. Getters, okay, getters, setters are here, nice, okay. By the way, I didn't do any validity check if it is negative, positive, etc. Okay, and print check says that, well, I cannot do anything. Okay, it says that function called for an undifferentiated employee. I mean, it looks like print check doesn't know what to do, because when you write the paycheck for an employee, you need to say things like you have worked this many hours, or this is your weekly check, or you sold this much thing. So this guy doesn't know about how to write this print check. So it write this error message and it exits 1. Doesn't make much sense, this print check for this class. So it looks like I am not supposed to call this print check, because it doesn't make much sense. I mean, I cannot be a simple employee. If I am an employee, I am a monthly employee myself as a government employee, my pay is monthly. So every month government tells me that, okay, this is your pay for this month. It's a monthly pay. There are some people that get paid by the hour they work. There are some people that get paid by the amount of sales that they make. They say that, okay, this is your commission for this commission this period. Okay, you sold this much good, and this is 10% of the commission, something like that. So for this one, they say that I don't know what to write in here, so I am going to exit. Don't call this function. Okay, so it is easy. It's an easy class and functions to write. As I said, we could have written this some time ago. So let me try to draw the UML diagram of this employee class. So private name, it is string, SSN string, and pay is double. And of course I have my constructors, two constructors, get name, set name, etc. Okay, so this is, I didn't write everything. Okay, so this is something, a diagram, UML diagram, remember? Okay, did your TAs talk about producing code automatically from a UML diagram? Did they talk about it? You draw your UML diagram like this, using, of course, a computer tool, and you ask that tool to produce the UML, the C++ code. Did they talk about it? I forgot to tell them. Maybe they talk about it. Did they? There are tools that's called computer aided software engineering, case tools. Okay, case tools. Those case tools are very useful. When you run this case tool, it lets you draw UML diagrams like this. You give the name of the class, you specify the data members, and you tell that I need the getters and setters for this one, constructor, and etc. After you do all that stuff, you ask the case tool, produce me the C++ code for this class, or produce me the Java code for this class, or produce me the C# class for this code, for this UML diagram. Okay, so you don't design your classes using C++ or Java. You design your classes using this abstract tool named UML, Unified Modeling Language. So it is a very nice thing, case tools. And these case tools are so nice. If you have code like this, okay, if you have code like this, employee H, you give this code to UML, you give this code to your case tool, okay, case tool, and that case tool can draw the UML diagram for you. Okay, so we are not interested in, I mean, as the if you look at your software project from a very abstract point of view, we are not interested in the code at the beginning. We are interested only in the general planning. We are only interested in the general class structure. Once we design the general class structure, coding is not that difficult. Any programmer can do that. Okay, the important thing is the general class structure. So those case tools will help you develop those general class structure for you, and after that they will produce the code. Of course, that code is going to be modified. It's not going to be perfect because they don't know all the details. The detailed code, the implementation of some of the functions has to be written by yourself. Okay, but it will handle most of the, for example, it will handle these guards for you, includes, or they will be all handled. Namespaces will be all handled with the nice names and everything. Okay, this public section, private section, everything, all the constants and everything will be handled. But when it comes to writing the employee CPP, maybe some of the things, for example, this print check doesn't know how to write this thing because only I know it. Okay, so you're gonna add only important implementation details. Okay, so I wrote my UML, I draw my UML diagram for this employee. That's nice, good. So let's continue and let's write another class. This class is going to be Salaried Employee. Salaried Employee is very similar to employee class, but this employee has a salary, fixed salary. What do I mean by fixed salary? Every 2 weeks, I have to pay $500 to this employee. So it is their salary. It's like myself. Every month, the government pays me some amount of money. Okay, whatever I do, okay, my salary is fixed, and the government says that, okay, this is your salary for this month. Net pay is different because with the net pay is the amount of money that I get after the taxes and all the deductions. I don't know in Turkish. I think in Turkish salary birisi brüt, birisi net herhalde ya. Brüt fazla olan mıydı arkadaşlar? Brüt şu kadar, net bu kadar falan. I think it is like that, okay? That is the salary after you take the taxes and all the deductions, you get your net pay. Okay, so it looks like the salaried employee is very similar to what? Is very similar to employee class. In fact, if I put them one by next to each other, can I do the, what is pencereler? Can I do them side by side? Sırala. No. Görünüm. Do you see it? I like to show these two header files side by side. I couldn't find, I remember I had it. Can I do this? Take this and move it? No? Okay. I couldn't, diğer görünüme taşı. Yeni uygulama penceresi. Oh, okay, good. Yeni uygulama penceresine taşı. Now I have two of them. This is one. Where is it? Okay, this is one, and this is the second one. Employee H. As you see, if I show them side by side, okay, they are very, very similar. Only on the left, I don't have the salary. Since I don't have the salary, on the left, I don't have the get salary and set salary. All of them is exactly the same, of course, other than the constructor names and etc. With the constructor this one, it will be there will be additional salary field. Okay, so good. So let me put this back in here. Can I do this? I could. Okay, good. So So I see a problem here. What is the problem? Oh, I am out of time. Well, maybe I will continue a few minutes and we will take a break later. The problem is this: even when you look at the implementation is almost the same. I mean, this dot dot dot. It is exactly the same as before our employee class. The additional thing is setter and getter for the set salary, get salary, and print check makes sense now. It says that I am printing the check. Okay, I'm setting the net pay. Okay, I'm saying that my pay is same as the salary. It looks like there is no tax deductions. Okay, pay to the order of name to the sum of this much, and employee number is this. So I am saying that this employee is going to, this salaried employee is going to get this much of money from myself. So this is a check that the employee can take to the bank and withdraw the money. So I know how to write this print check now. So employee is a salaried employee class is a more usable class because it knows how to print the checks. Okay, so what is the problem? The problem is these two classes are so similar to each other. I don't like it. I don't like these kind of similar classes. Why? Because I have copy-pasted stuff. Their interfaces are almost the same. Why am I copy-pasting it? I mean, salaried employee is very similar to employee. The only difference is it has more stuff, salary, right? So C++ says that if you have classes like this, very similar classes, you can tell this to compiler. You can tell this compiler that salaried employee is exactly the same as employee, only I have two additions, get salary and set salary as the functions, and salary in the private data. So compiler will know about the similarities between them. And I don't have to repeat the code. And that's called inheritance. Okay. After the break, we will come back and we will show you how to do this inheritance without writing all this code again, over and over again. Okay. So let's take 10 minutes of break. After the break, we will continue talking about inheritance. Let's be here around 11:40. 10 minutes. By the way, whoever sent this, oh, what's going on? Can I show you this? No. Can I? No, I cannot. Maybe. Let me turn off my background. Yeah. Get rid of my backgrounds. Yeah. Okay. Whoever sent this, thank you. We miss you too, and we hope the same for you. Okay, so we talked about inheritance. We said that we are going to do inheritance, and inheritance is going to let us write new classes that are similar to our previous classes, and we are not going to do any copy pasting. We are going to only say that, okay, my class is very similar to this class, only I have these additions. Okay, this is what I'm going to do. I will say that again, I am using a UML diagram. This is a special notation. A new class, salaried employee, is a new class, salaried employee class, and my salaried employee class in its private section has only salary. It is double, and it is public section. It has the salaried employee constructor, and this one will take a string for the name, another string for the social security number, and the double for the salary, and of course the print check will be changed because the print check of employee we didn't like. So that's it. Salaried employee will have all the features of employee, including the getters and the setters for the name, social security number, salary, and everything, right? Everything. And other than that, I will add the salary, and I will add the set get salary stuff. Okay, so these are the only differences. The set name, get name, set social security, get social security numbers, and net pay, get pay, set pay will all be available in the salaried employee class. Okay, so let's look at how this is done. Let's look at how this is done in C++. In UML it is so easy. But in C++ it is as easy as doing this drawing. So let's see. So this is our previous salaried employee class, and let's see the new salaried employee class. Okay, this is header file for the salaried employee. Okay, this is the header file for the salaried employee, new salaried employee. Okay, my namespace. See, I included employee age. And then what I do is I declare my salaried employee. With the salaried employee, I only in the private part I have the salary, and I have get salary and set salary, and I have my print check, my constructors. That's it. But the only difference is this part. Say that the meaning of this piece of code is this: I am same as employee. This class is same as employee. The only difference is I have additionally this private data member. Okay, I have additionally this private data member, and I have additionally this getter and setter. Okay, getter and setter. And remember, in my employee class, I had this print check. I don't like that print check anymore. Okay, I am going to write my own print check. The rest is inherited. That's the name inheritance come from. That's where inheritance come from. Inheritance means miras kalıtım in Turkish. Miras kalıtım. I have inherited everything from this employee class. Now I am adding two things. Okay, there's salary private data member, and the setters and getters for this salary, of course, data member. And I am going to modify inherited pre-check function. I will not use it. I will use a different pre-check function now. Okay. So Burak Yıldırım has a question. What happens if we change the public with private where we inherit the employee class? Oh, you mean this public? Ignore this public for now, okay? Just memorize it as it is, okay? We are going to look at it, the private and some other types of stuff, okay? We are not going to use that kind of inheritance. Yeah, private is possible, but we are not going to cover it. Baran has a question about the midterm. What? I don't, Baran, I am going to send you the instructions for the midterm exam during the weekend, and you'll see it. So Nejdet has a question. Now, when we have to use employee, should we call employee from salaried employee? Employee is a class. Employee is a class. It is not called. What do you mean calling an employee? It's not a function. You mean if you like to use the objects of employee, you mean? Is that what you mean? As you see, I did not change anything about employee. Employee doesn't know that somebody is inheriting from it. So I am going to use employee as it is. Okay, let me write some code then. This is chapter 14, right? Okay, let me open up some example salaried employee, okay, maybe these two, this one and this one, open both of them. No, this one not good, I don't like it. I don't like it either. So let me make a new file. Okay, and I am going to, in this one, I am going to, of course, include employee.h, and I'm going to include salaried employee.h. Okay, and if I need to include some other stuff, maybe IO, stream, etc., I am not going to do that yet. Okay, and in my main function, all I am going to do is to, okay, let me employee E1 and E2. For the E2, Ali Demir is the name of the employee, and it needs the social security number. Let me type some random thing. Okay, these are my two employees, and I should have salaried employee S1 and S2, and for the S2, Ayşe, Yılmaz, and some random social security number. And I think the third one needs, okay, 5,000 Turkish liras per month. Okay, so I could say things like Ivan dot get name, no problem, Okay. And I should also say maybe s2.getName. Both of them should work fine. And let's do this then. And let's say e1, e2 dot, I forgot the functions. Let's look at the functions. Get net pay. Yeah, I have the get net pay. And these two should work fine. And this one should work fine. No problem. How about this now? Let's do this. Salaried employee. Okay, get salary. I am going to okay. So line 11 and 12 is okay. Okay, line 11 and 12 are okay. 14 and 15 are okay. How about 17 and 18? Would they compile? Would they run? It won't work for line 17. Why? Because line 17, E2 is an employee. When I look at the definition of employee, okay, I don't see any get salaries, right? Because salary doesn't mean anything for an employee. Salary is only meaningful for the salaried employee. Okay, salaried employee. So line 17 is a compiler error. No, this is a compiler error. Okay, but this one is okay. Why? Because if I look at the salaried employee header file, I see that get salary is there. But you might say that I don't see any get names here, okay? How come I can write the same thing? I don't see any get names. Do you see any get names? No. But I know that salaried employee inherits everything that employee has. Okay? Salaried employee inherits everything that employee has. That's why I can call the function, member function, get name, set name, get SSN, set SSN on all the objects of salaried employee. Okay, that's why this line is okay, and this line is okay. Okay, I think I have a few questions. Atakan has a question. Have we seen operator just like what? 2 minutes ago. What operator? You mean the column operator? I think he is asking. Again, we are wasting the whole class's time just because you are not using microphone. First, I need to spend 5 minutes to understand what you are asking. Do you mean this? Atakan, do you mean this?
Yes, sir.
Why don't you use your microphone to ask your question? This is not an operator. And yes, you did not see anything like this before. This is a specific syntax addition to do inheritance in C++. You are saying that I am a class, my name is, I am a class, my name is salaried employee. Okay, I am a class and my name is salaried employee. And I inherit everything from this class employee. And where is employee? Employees here. I included it. Okay. You could see the definition of the employee here. Okay. And I am same as employee. So what is your difference? My difference is I have two new constructors, no parameter constructor and the constructor that takes 3 parameters. Other than that, I have new setters getters and the print check function that I have inherited, okay, the print check function that I inherited is going to be changed. I don't like it. Okay, I don't like that print check function. And of course, in my private data area, I will add a new double for the salary. If we try to see what the memory looks like, let's say I have two employee objects, E1 and E2. Okay, remember the E2 is Ali want something like that, and I have salaried employee S1 and 300. If I have such objects, the memory is going to look like, for let's say for E2. For E2, there will be 3 places. One of them is the name string. Ali is here. And the other one is SSN. In this case, my SSN is 1, 2, 3, 5, 3, 4. And I think this is net pay. Net pay is going to be 0. Salaried employee, it looks like salaried employee in this case contains only a single double, but it is not actually. What did I say? Salaried employee S1 in it has an employee. There is an employee. And inside this employee, okay, name, SSN, net pay, okay. Name is going to be ICE, I guess, right? And SSN is going to be 17127591, and net pay is going to be some number, and then at the end I have this salary, double salary. I think it is 300. Okay, so S1 is like an object that contains an employee. It is like, what is this like? Do you see anything? Do you see any resemblance between S1 and some other thing that we have seen before? S1 looks like it is something of something. We have seen an example like this. S1 looks like something that we have seen before. It is very similar to Kamil, exactly. It is like composition. It is like there is an employee object in S1. It is like composition, but it is not composition actually. And they are similar, yet there are very big differences between them. Okay, so composition is an example of code reuse. Why? Because we are using already available class inside another class. This is similar too. Okay, this is similar too. For example, I could have used, remember our day of year class? Day of year class. Remember that class? Inside that class, I had day and month. Okay. Maybe I could have used this day of year as a composition. Remember this diamond thing? For birthday, okay? Employee birthday, okay? I mean, so that I can send some presents to the employee. I could have used as a composition. So this arrow shows the inheritance. This is composition. Composition is different from inheritance, but it looks like they are in a way similar because they are both examples of code reuse. We are saying that I have a day of year object inside my employee, but this one says that, okay, this one is going to say that I am same as an employee. This one says I am same as an employee, only I have more additions. This one says that I have day of year as one of my data members. So we will come back and we will talk about this later. Okay, so it is important to keep this composition in mind. Composition and inheritance are very closely related, and they are always mentioned together, and we will see why. Okay, good. So do we have another question? Mohammed says, can we overload the employee function in salaried employee adding? What is employee function? Mohammed, you mean the employee constructor?
No, not constructor. Member function.
We don't have a employee member function in salaried employee.
Like get name or etc.
Well, you could, yeah. I mean, let's look at this salaried employee. If you say, I am doing this, void set name, and set name, I guess, will take okay. If you do this, this is not overloading. Not overloading. Why? Because it has the exact same signature as the employee's set name. This means that you are redefining. Redefinition. Okay. So you are redefining the meaning of set name. It is like print check. Remember, we had print check in employee age. This print check and this print check are exactly the why don't I have a constant here? Okay, are exactly the same. Their signatures are the same. So this is redefinition. In inheritance, you inherit everything, but you get to say that I don't like this function that I have inherited. I am going to redefine it. Okay, I am going to redefine it. Overloading and redefinition are two different things. Okay, redefinition only happens with inheritance. Okay, did I answer your question?
Yes, sir. Thank you.
Okay, any other questions? Again, remember why we are doing this. Remember this class, salaried employee, that I wrote before? This is exactly the same as the employee class. Only thing is that I have added this weekly salary. Every week I am going to pay this much. Okay, so the weekly salary doesn't have to correspond to net pay because it could be different. So I am adding this salary, but the rest is the same. Setters, getters, etc. For the new part salary, I added this setter and getter, and print check is going to be changed maybe. So I don't want to repeat all the code, especially with the implementation. Instead, what I am doing here, I am saying this. I am saying that I am same as employee. I am adding this new salary field, private data member. Also, I am adding this setter getter. Also, I don't like this print check function. I am going to rewrite it. I am going to redefine it. redefinition. Of course, this class has to have the constructors of itself. Burak Yıldırım, yes. Can we overload a function we inherited without redefining it? You could, but those kind of things are very confusing. Overloading an inherited function is confusing. Usually we don't do that kind of stuff. Okay. Sorry, I had to take this call. Efendim? Buyurun. Teşekkürler. Siz nasılsınız? Evet, bugün bir ziyaretim var. Eğer ilgiliyse olabilir. Gölcük'te. Yani projeler neyle alakalı? Kameralarla falan mı yoksa doğrudan şey ya? Tamam. Tamam, yazılımsa bakabilirim, evet. Tamam, oldu, bekliyorum. Tamam, teşekkürler. İlhan Bey. Teşekkürler, iyi çalışmalar. Görüşmek dileğiyle. Sorry for that. Yeah, we don't do that kind of stuff. Can we do constructor inheritance? Constructor is already everything that you have in the class employee is inherited. And actually, I did not show you how to implement this new salaried employee class. Let's see, and some of your questions will go away. Okay, let's look at the salaried employee implementation. Okay, this is the implementation. I included salaried employee.h here. And namespace service salary is nice. This is the no parameter constructor. See what the no parameter constructor does. We understand this one. Salary is our new private data member. I initialize it as 0. Yeah, that's no problem. But it also says that I am calling the employees constructor. Remember, I said that I am same as employee. And remember this figure? Inside the salaried employee, there is an employee object. Okay, there is an employee object, really. Okay, inside the salaried employee, there is an employee object. So who is going to initialize it? Of course, the constructor of the employee is going to initialize it. I don't care how it is initialized. All I am saying that I am same as the employee, so let the constructor of the employee handle the initialization of the employee part. I am only responsible for initializing the new additions to this class. Okay? So Mehmet Hussein, this is kind of an answer to your question. The constructor of the employee class is inherited, and I am calling it here. Okay, this is a no parameter constructor of the employee class. Let's look at the other constructor, the constructor that takes name, TC kimlik numarası, social security number, and weekly pay, salary. So I say that I am going to call first the base classes constructor that takes 2 parameters, new name and new number, right? So the name of the employee and the social security number of the employee. That's how the initialization is done. This is the constructor of the employee class, and this is the initialization for the salary. And again, this is deliberately empty. I don't do anything. Okay, so this is how you implement the constructor of this new class salaried employee. It is simple, right? I mean, I let the employee class do all the initialization regarding the employee. The new additions here, salary, I handle it myself. Of course, with this class, since I added a new data member that needs the getters and setters, set salary and get salary, I do that. And I have my print check here. They forgot this const thing. I'm not modifying anything. Oh, no. Set net pay. Oh, that's bad. Okay, that's why they don't have the const. They don't have the const. That's why they have it. Okay, then I need to go back here. Where is this thing? And take the thing out. So this is not overload. This is a definition. This is something stupid. I don't like this code, but this code from the book. Okay, because set net pay is not a constant. If I make this a constant, this is a compiler error. Okay, print check. It says that to be able to print the check, my pay is same as the salary, and this is what I'm going to print. See, this one is like get net pay, get SSN, get name. It is calling these functions like they're their functions because I am really an employee. Okay, I have whatever the employee has, everything employee has, I have them. That's why I can call them get name, get net pay, get SSN, no problem. I can call any of them. It's like they are my functions, and in fact, they are my functions. That's one difference between composition and inheritance, right? With the composition, you have to say that I am going to call this function of this object. With the composition, remember, I had to do that with the composition. With the inheritance, I can call these without saying anything. Those are my natural functions, no problems. Okay, let me go back to the slides and let's start talking about the basics of inheritance again. And I will go over these ideas over and over again. I am trying to teach two things to you. One is the idea of inheritance as a general concept, as an object-oriented programming concept. The other thing is how we do this kind of stuff in C++. We are going to do both at the same time. Okay. So Nejat has a question. If my employee class includes a dynamic array and includes a destructor, salaried employee object will die. Do it call it automatically? We will talk about that. And there is this. Remember, we have this PF array D, partial filled array double class. We are gonna use inheritance to make a new class from that class. Okay. And we will see examples of exactly what you are asking with that one. Okay, so what happens with the destructors? What happens about the dynamic variables of the employee class, etc.? Yeah, that's a good point, but I don't know why 3 people are angry, but we will come to it. Okay, we will come to it. So 2 people are angry now. Okay. That's not an early question, actually. That's good. What are you guys doing? Okay, let me give a thumbs up to Nejdet then. How are you guys doing it? Thumbs up. I think I did it. Ah, okay. That 4 is mine. Ah, okay, good job, Nejdet. Okay, so introduction to inheritance, object-oriented programming, powerful programming technique, abstraction dimension. Okay, I abstract away all the details of employee and I think myself as an employee. This sentence is important, very important. It doesn't make much sense, but this is what you do. You write a class in a very, very general form like an employee class, and then write another class called Salaried Employee, which is a specialized version of the Salaried Employee. Okay, so here, Salaried Employee is a specialized version of employee. It is exactly the same as employee, but it does extra stuff, but like it is doing the salary stuff. It's like this. This inheritance is very commonly used to explain concepts. It's like, I don't want to give wrong examples. Okay. Vehicle or motor vehicle, maybe. I have a motor vehicle class, motorlu taşıt, and I have another class, automobile. Automobile is exactly the same as motor vehicle, but it's a specialization. Inside the motor vehicles, there are many things like motorbikes, right? Okay. There are tractors, there are trucks, there are three-wheeled stuff. I don't know. There are construction equipment, etc. Automobile is exactly same as motor vehicle, but it has extra stuff like usually the automobiles are either four-door automobiles or two-door automobiles, right? Okay, so with the automobiles, all the automobiles are four-wheel vehicles, right? They are all four wheels. They are special motor vehicles. So maybe I could do another one. Motorcycle. Okay, motorcycle is a motor vehicle, but it has two wheels, and it doesn't have a cockpit. Okay, it doesn't have a cabin. You are all exposed. Okay, you are all exposed. Maybe I can continue doing this. After the automobile, maybe I can say convertible. Convertible auto. Üstü açık arabalar var ya. Convertible auto. So it's an automobile. It has four wheels, but it doesn't have a top. It doesn't have a roof. Okay. So this kind of reasoning is very common in the general world. It doesn't have to be all about software. And we are using the same idea, this inheritance idea, hierarchy idea. This is hierarchy. Okay, hierarchy idea. In software development, it's very, very useful. So this is more general. This is more specific, even more specific. Okay, number of motor vehicles in Turkey is maybe 5 million. There are 5 million motor vehicles, but there are only 20,000 convertible automobiles. So the class of motor vehicles is much larger than class of convertibles, because there are 5 million motor vehicles in Turkey. Only 20,000 of them are convertible automobiles. Okay, so you may think it that way too. Okay, there are okay, this is exactly the same here. Okay, there are employee objects and there are salaried employee objects, and salaried employee objects are specialized versions of the employee objects. So this is what we do. We write the general form of the class, which is the employee class, and then we write our specialized salaried employee class. Okay, and our specialized class should add new things to it or should modify some of the things. For example, I added salary, getir salary, and I modified the print check, right? I modified the print check. Okay, so this new class is inherited from another class. This is some terminology. Okay, let's go back. This is called inheritance. This part is called inheritance. Inheritance. This is composition. Okay. For the inheritance, this is an employee is a base class. Temel sınıf, base class. And this is called derived class. Derivation. Türetilmiş sınıf. In Turkish türetilmiş sınıf. Temel sınıf, türetilmiş sınıf. Kalıtım. Inheritance is kalıtım. Okay. This derivation is same as the calculus derivative, türev. Matematikte gördüğünüz türev var ya. Türev. It's the same word. Okay. Derivation. This is a derived class. I derive the salaried employee from this base class employee. This is called base class. This is called derived class. Okay, this is some terminology of inheritance, and we are going to talk about these later. Okay, base class is a general class from which others derive, and derived class is a new class. Okay, and it automatically has base classes, member variables, and member functions. Also, I can add new additional member functions and variables if I like to. Okay. So, some terminology, but it looks like I am out of time. If you guys have any questions, if you guys have any questions, I can answer. Otherwise, I will
Sir,
stop.
I have a question about Moore.
Okay.
I got two questions about Moore actually. In Homer, it doesn't explicitly say we should implement the big three. Should we implement the big three since there is a there is a pointer in the class?
If you don't implement your big three, your class will be a wrong class. If somebody uses your class's object with call by value, okay, you'll be in trouble.
Yeah.
So it is up to you. If you like to submit a incomplete class, we are gonna grade it accordingly.
Okay. And there is we should implement a score mechanism.
Yeah.
But it is all up to us to implement score
Yeah,
logic.
the algorithm is yours. I don't know how you come up with the algorithm, but you should find a way of measuring how good the board for the user or the computer.
All right. And are we gonna see move semantics?
Maybe I will. I don't know. Because I mean, after the big three, it comes too much for some of the students. Maybe at the end of the semester, I will make a decision. I will talk about it a little bit, maybe at least, but I don't know how detailed it's going to be covered. I don't know.
All right. Thank you.
Okay, so that's it for today. Nejat, it looks like the angry people are more, so I am changing sides. I wanna be with the winning people. I can't. Why I cannot do that? Okay, so I am with the others because 12 is more than 6. Sorry, Nejat. That's what they do all the time to meet you. They stab you from behind. Okay, that's it for today, and I will see you tomorrow morning.